All right, as we continue with the linear systems, which is the 4-1, 4-2 material, sometimes you come across a problem like this. And notice the difficulty here. It's not horrifying, but it's just something we haven't had to do yet. I have a 3x on the top and a 2x on the bottom. Let's say I'm in the bottom equation. Let's say I'm trying to eliminate these. Here's how you go about doing it. You ask yourself the question, what is the smallest number that 3 and 2 will both go into? And of course the answer is 6. So what you're then going to do is you're going to make one of them say a positive 6 and one say a negative 6, and then they will eliminate. If I multiply the top equation by 2, this 3x will become 6x. If I multiply the bottom equation by negative 3, this 2x will become negative 6x. And then the positive 6x and the negative 6x will cancel. So let's do it. The top equation by 2 becomes 6x minus 18y equals 162. The bottom equation multiplied by negative 3 will become negative 6x minus 18y equals a positive 30. When I add them together, the x's eliminate. I'm left with a negative 36y equals 192. When I divide by negative 36, I get y equals a negative 192 over 36, and that reduces to negative 16 thirds. It reduces to that because 12 is a common factor of top and bottom. Now, what I need to do next, you've got to see not all answers always come out to be integers. But what I do next is this. Let's say I take the top equation, okay? Negative 3x minus 9y, which is negative 16 thirds, is equal to 81. When I'm multiplying these together, look what happens. The 3 goes into the 9 3 times. Negative 3 times negative 16 is a positive 48. 3x plus 48 equals 81. Subtract 48 from both sides. 3x is 33. Divide by 3, x is 11. Our ordered pair answer is 11, comma negative 16 thirds. This is a consistent and an independent system. In other words, it looks like an x. Now, this next system is best done by using substitution. And the way you can tell the difference or to decide whether to choose which method, I would probably not pick graphing ever unless somebody made me. So I would either be doing elimination or I would be doing substitution. Notice over here where we used elimination how the x's were aligned, the y's were aligned, and so were the numbers. Over here that's not the case. Substitution is best done when one of the letters is already alone. So look what happens. It's really kind of clever. Y equals 3x. So what that means is, in this system, anytime I see y, I can substitute it with 3x. Well, look what happens. I go to the top equation, and when I rewrite the top equation, it becomes 2x plus 3x equals 15. 5x equals 15, therefore x is 3. So I have half my answer already. And now what I'm going to do is I am going to take x is 3, and I'm going to go into either equation, but I'm going to pick this one right here and substitute in. Y is equal to 3 times x, which is 3 times 3, or 9. Therefore, my solution set is the ordered pair 3, 9. Again, it looks like an x. There are 2 lines crossing there. It is both consistent and independent. This system, x equals 8y minus 4, and x plus 8y equals 6. Substitution is calling your name because top equation has the letter x alone. X can be replaced with 8y minus 4. So that's exactly what I do. I go to the bottom equation, and where I see x, I put in 8y minus 4 plus 8y equals 6. Collect like terms. 16y minus 4 is 6. 16y equals 10 when I add 4 to both sides. Divide both sides by 10, therefore y is equal to 5/8. When I go to the top equation and substitute in y, I will get x. X equals 8 times 5/8 minus 4. Remember that 8 is really 8 over 1, so the 8's cancel, leaving me with 5. 5 minus 4 is 1, therefore x equals 1. I have the ordered pair 1, 5/8 as my answer. That means the two lines cross in that one location. It is therefore consistent and independent. This next equation, or rather the next system of linear equations, I'm not going to do with substitution. I'm going back to the elimination or the addition method. And to me, the easiest variable here to get rid of is the x. If I got rid of the y's, I would have to do something to both top and bottom. But if I get rid of the x's, all I have to do is multiply the bottom equation by -2. That will make this a -4x, and the positive 4x on top will eliminate with it. So when I multiply the bottom equation by -2, it becomes -4x minus 6y equals -8. The top equation stays the same. When I collect like terms, I get -y equal, well, when I, do my elimination, I get a -y equals -2. That negative is really a -1, which I can't have remaining there. So I divide both sides by -1, and I get y equals 2. When I go to either one of these equations, I just happen to pick the top one, and I plug in a 2 for y. This becomes 4x plus 10 equals 6. 4x is equal to -4. Divide by 4, x is -1. My solution set is the ordered pair -1, 2. Again, it's two lines crossing in the form of an x. It is therefore consistent, meaning there's at least one answer, and it is independent. Independent means the lines either cross once or never. Dependent means they cross all the time. And I will go on to the next movie with these systems. So let's call this one done.